It looks like the new year is off to a good start so far. Hi, everyone, and welcome to 2024. Happy New Year and happy new DSS break. It's great to have all of you joining us today. We're here live every other week to discuss the world of data science, AI, and machine learning, and chat about unique experiences and best practices with leading data professionals in a 15-minute break. I'm Anna, the founder of Data Science Salon, and today I'm streaming directly from our HQ, which is located in the heart of Miami, right next to the design district. And today I'm joined here by Benjamin Skyenka, data science manager at eBay, and Vanguard and data science and casual inference, with a robust background from Princeton to UCL and experience at industry titans like Amazon, and now you're at eBay, and your expectations pretty much drive smart decisions in these tech companies. So it's really awesome to have you here, Ben. And you're one of our on-demand speakers also for our upcoming event in Seattle. And you're going to be talking about how to drive experimentation best practices using a maturity model. So it should be very interesting conversation, very specific to this industry. So I think people are really excited to see your talk. So why don't we go ahead and dive in? And thank you so much for joining us. And thanks for being with us, Ben.
Thank you so much for the warm welcome. It's always great to be at your events. You run a tight ship, and so it's always a pleasure to participate and interact with your audience.
Thank you so much for supporting us. Yeah, I think you and I met, gosh, back when I was a Domino, I feel like, right? Like even before Data Science Salon came about. So I think it's been a while. So it's really nice that you've been supporting us for so long. I would love to hear, I don't think we've ever really talked about how you got into data science and how how your journey has shaped your current role that you have now at eBay. I would love to hear that story, Ben.
Right. Well, as you can all see, I don't have a full head of hair, so I've been doing this a while. And so I would say I was always a data scientist, and we just didn't have the title. And, in the 80s, when I was going to university, I was writing software to answer scientific questions. And that was always what was exciting. Data is this Agatha Christie mystery, and I wanted to go solve it. And I realized that in order to do that, I needed software engineering skills. And kind of on the education side, how I got there, when I think about this question, right, I could talk to you chronologically, which is probably less interesting, but I think there are a couple people who are influenced me and helped me become a data scientist. And the first was, as an undergraduate at Princeton, I was really lucky to work with John Wheeler. I was majoring in physics. I thought I was going to try to answer questions like, where does time come from, and other simple solvable problems. And Wheeler was a disciple of Bohr and Fermi, so he just infused me with that classic approach to doing science, and also intuition, because Wheeler would say, never calculate anything until you know the answer, which is right. You should have some intuition, and results should make sense. And if there's surprises, we need to understand why. And then the PhD program that I started pursuing in physics wasn't a good fit for me. So I worked in industry because I realized I needed to learn how to write software. I didn't know how to write software. And I could see in the 80s that was the future. If I wanted to do science, I had to learn how to write software. So I worked in a variety of jobs in the software industry and learned how to write code. And then I ultimately went back and did my PhD in economics because I got curious about human behavior. And there I was really lucky to hook up with Ken Judd, who's the top computational economist in the world. And also got exposed to my academic grandfather, Jim Heckman, who, if you're an economist, you know what that means. And he has a very rigorous approach to doing science based on structural models. And also at Chicago, which is an amazing place to do science of any kind. I was lucky to do my postdoc with, ironically, a physicist, Bob Rosner, who taught me about something called VV and UQ, which is a framework for thinking about correctness of models. And we've talked about that in other data science salon editions. And then the last thing I'd say is just a call out to a colleague I worked with in industry, Art Munson, who taught me about crisp DM, which is a great workflow for doing data science. So kind of all these pieces come together, and I bring that to what I do, which is trying to solve practical problems that make people's lives better.
Cool. No, that's a really awesome journey and story. And thank you so much for sharing, Ben. And why don't we go ahead and dive into ethical AI, and what does ethical behavior and AI mean to you exactly? And how do you integrate it when building an experimentation platform? Because you've done a few of those. So how do you really think about this from the perspective behind the scenes, I guess? Because I feel like, people think of it from more of what it's going to do to the customers, but what happens in the back end is also very interesting to know.
Yeah, this is a great question. There's so many parts, and we could probably talk about this for many hours. And I think now everyone's talking a little bit about, Asimov's 3 laws of robots because of all the news about DeepMind and Google. But I think when you talk to a young scientist, one of the things you say, I had a Canadian colleague who's like, hey, don't fail the Globe and Mail test, which is, you don't want to do something as a human that you wouldn't want to read about in the Globe and Mail, which is this famous Canadian paper. And so maybe if we think about AI, we can also apply something like a Globe and Mail test, You don't want to read about your AI system in the newspaper because it's doing bad things and that are unethical or producing weird results or, causing any variety of problems, whether it's, trading mistakes in an algorithmic AI system or other more ethical things or applications we'd rather not think about, like in the military sphere. But I think that one way to think through this in a principled way is, we don't want our AI to fail the Globe and Mail test, so we can think through this in this framework of the crisp DM workflow. And so we really start with, the first thing is you don't want to build unethical systems, We start with the business question. There are certain companies and problems that as a data scientist, maybe you don't want to work on. You don't want that on your soul. And we start there. And then the next part is, so then we move into data, these systems hinge on data. And if we don't have a good data set, we're not going to be able to build a good model. So you really have to invest in building these high quality data sets that are going to allow us to build an ethical model and system. And then as we do modeling, we have to make ethical choices. So for instance, you can't use certain data that would cause unethical things to happen. Like if I use zip code in my financial model, I might end up discriminating against people of a certain race or subgroup because zip code proxies for those things. And in fact, in some finance companies, it's actually illegal to use zip code in your model. So you have to be very careful then about the data, the feature engineering you do. Then when we move into thinking about evaluation, certainly we need to do all the standard stuff to make it work, but we should be running things like a customer lab. You probably want to set up a red team who's going to try to break it. Like if you have a chatbot, see if they can make it do something bad. We also, as we're building these models, we want to think about incentives because incentives affect our behavior. So you might have something like a model review board, You should have some external body in your company whose incentives are to make sure we do ethical things, not that we ship product at high velocity, because those things may be in conflict. And the people who are doing the reviewing need to have an independence and the right incentives so that they can do what's right overall for the company and society. And then lastly, when we get to deploying, we need to do so with sensible safeguards. So you may have some kind of on-duty watch officer who, as we ramp this thing up, if we see bad stuff happening, he can kill it or she can kill it. And so we need to have things like a kill switch. We need to ramp sensibly, and we need to have ways to evaluate and monitor whether or not behavior is ethical. And these are all hard problems we could talk about a long time. And then, so that's the first part, the whole ethical part. And then there's also a separate thing that's existed even before AI, which is running ethical experiments. And there's some companies in Silicon Valley we won't name who've run unethical experiments that you would never get past a human subjects committee at a university, like trying to manipulate people's behavior or how they vote. Again, we shouldn't do those things. And then I think the next part is when we integrate AI into experimentation systems. Remember, we're running experiments because we want to make better decisions, and the AI should support that. So as I think about building my platform, I want AI to lower the bar for experimentation and make it as easy as possible for people to make good decisions. So that means making it easier to run experiments. And the goal is to be able to run a high quality experiment, make a good decision, and not know any statistics. And maybe that's not attainable, but we can get closer by using AI to do things like help someone stand up an experiment from a business question. I built a POC to do that recently. It was pretty exciting. Automate things like helping them with analysis and making launch decisions and providing things like launch announcements so that we can communicate and disseminate knowledge and learning throughout the organization. So there are a lot of ways we can then use these AI tools to improve how we run experiments, make it easier, and lower the bar to getting a good decision. So,
I think that, yeah, this is a great answer. I feel like you could probably write a whole blog post to do like a whole presentation on this for sure. That's a great topic. We should do that at another DSS event for sure. But that goes into my next question. Have you encountered challenges when advocating for these best practices, and how do you usually address them? Because I know I think everybody's aware that there's a lot of companies and the Valley and, beyond that they don't do this correctly, right?
Yeah, and I think it's still new and we're still figuring out how to do it in some ways and what are the right metrics and how do we measure it. So it's a very, very foggy time, right? There's still this fog of war. And in retrospect, all the decisions will be clear. And I think we have to give everyone in this environment a little bit of grace because we're going to make a lot of mistakes until we get this right. And then when we look back in 5 or 10 years, we're going to be like, what were those people thinking who were doing that? That was clearly, bad, or, oh, those people were super smart. So I find when I have to deal with science problems, it's never infrastructure or methodology. It's very rarely infrastructure methodology. It's almost always culture. And so it's culture. And so there can be these tensions in terms of how the incentives are set up in our culture, like this priority on velocity over correctness, and as part of correctness, I think I would include ethical behavior in correctness now. I think it's fair to include that. It's not just, does your model make good predictions, but, do we get ethical outcomes? So you want to think about incentives, and culture really matters. And part of how we overcome these problems is building trust. And trust can take a lot of time to build, particularly when you are dealing with people who are convinced, where you have two parties who are both convinced they're right and they disagree. And for some people, this can take on religious levels of conviction where they want to demonize the other party. And there's something called the certainty trap. If you don't know about that, it's worth researching. Alana Redstone's done some research on that. And we begin by asking questions to understand their position, assert on our right to ask questions, and then engage with these people in a way that we can build trust. And that can require steady, sustained, considerate pressure over time. And also, I try to understand their incentives that are causing them to behave the way they are. As an economist, we think a lot about incentives and trying to align incentives so we get the behaviors we want. I learned a really wonderful method from my manager, who's really, really good with this political stuff. Like, you don't want to call out people for misbehaving. It's better to send out regular reports with data that just shows who's getting stuff done. And we can use this to help build trust. And so we can say, like, these are the things we've agreed to, that we each agreed we were going to do. This was our contract. But I think you'll find that most of the problems are still at the human level. And sure, there are things we could do to make infrastructure methodology better, but it's cultural.
Yeah, no, that's a great answer. And I think that also answers the question I had about, people that are going into the field and such, what advice. It sounds like, just building trust and being more of like also trying to have more of those other skills, right? Versus just being very technical. So it sounds like you need to have all of that to be successful,
I,
and like with everybody to gain trust, right?
Yeah, I think that as scientists, right, many of us come to science because kind of the way, athletes were good at their sport, they were naturals, math and science and programming, or these other things were easy for us, and maybe people were less easy. And there are exceptional scientists who have incredible social skills and huge extroverted personalities. But, many of us, we'd rather be left alone in the lab or be in an environment of small people. And so I think the first thing is you really need to invest in those soft skills, because that's how you get done. That's how you advance in your career. Most of the people you deal with cannot evaluate whether or not your work is correct. And this was really clear when I worked as a consultant running my own consulting firm. My clients could measure if I shipped on time, but they almost never knew if
What
my
you're shipping. Yeah. What is it?
right? Shipping's clear, right? Did you get something on a certain date that didn't crash when it was deployed to production? So I think learning how to deploy and work with engineers and get stuff deployed is important. That's how you get stuff done. But learning those soft skills, like how do you negotiate with stakeholders who maybe you don't agree with? How do you deal with difficult managers, one or more layers above you, who are trying to impose some agenda on you that is wrong? And also there's humility to understand their perspective, but learning how to interact with these situations and not capitulate. It's very hard early in your career when there's fear of losing your job. I mean, I'm an older guy. I know that if the worst thing that happens is I go off and consult again, and that's fun. I like that very much. But you have to kind of be samurai-like and not be afraid to die, because if you sell your honor, you're never going to get it back. And then the other thing is, this is a long-term game, right? You need to continue to invest in your human capital, both the technical skills and the soft skills, and have a very long run view, because 5 or 10 years is going to be on you before you know it. And if you've done things right, you'll be positioned to be, a director or a technical lead, or whichever path you want to be on, whether you want to go into the data science management or remain in an IC, individual contributor. But talk to a lot of people too. That's the other thing about how they got it.
That's really great advice. And I think, it's a long game, I think in anything that you're doing, if you want to do it right, and you want to be an expert in your field, it doesn't just take 18 months to do so, to gain that expertise, right? I feel like a lot of the newer folks that we see coming in just any industry just expect results too quickly sometimes, right? So
yeah, it's easy to be impatient. And the other thing too is, money isn't everything. It's better to be at a good company that's ethical, where you can learn and grow and develop as a person and as a scientist, than to make an extra $10,000 or $20,000. And also, choose employment that matches your lifestyle. And I have an employer we negotiated, and I'm able to live in Sonoma, which is where I want to live, right? And you've made choices too, so you can live in Miami, which is where you want to live, because I know you don't want to live in Sonoma. That's like your
yeah, exactly. So I think, that's great advice. And I think, like I completely 100% agree with you for that, for any kind of position or industry. I feel like that's the same, right? But thank you so much, Ben. It's been really great to spend some time with you today. And thank you so much for sharing some of this great information. Really excited about your talk as well, because I think it's going to be, just very interesting to see that very specific use case. And for those of you guys that are interested, join us virtually, or you can come in person in Seattle if you're in the area. We are almost sold out, so make sure to grab your spot. And it's only 2 weeks from now. Really excited. It's our first event of the year. So I love to kick it off with, right as a first event, because I feel like people remember it the most, remember your event the most as the first one. So
cool. Yeah, and Seattle has a great community, and I have many friends there. I'm sorry I can't join you in person, but if you want to learn how you can improve your science platform, whether it's experimentation or machine learning, take it to the next level, check out my talk, and I'll show you how you can use a maturity model to do that. And hopefully I can attend the next one. So thanks again for this opportunity. And I wish you a wonderful conference and rest of the year.
Thank you, Ben. And thanks everybody for joining. Enjoy the rest of your week and have a great weekend. Bye.